Alright, so we're going to briefly review a complex number or imaginary number and see how these work with our polar form. So basically we have this definition that I is the square root of -1 and I squared is -1, and we try to factor out this -1 and then make it an I value. So we can take root of -24, which is not a real number, and then we turn it into 2 root 6, which is the square root of 24 simplified, times I. And then same idea here, we have -1s in there. And so we get 8i, 6i, I squared is going to be -1, so we get a negative 48 as we look for this. For these ones, we have some patterns that pop out. I is equal to I squared is -1, I to the third is I squared times I, so it's negative I, and I to the fourth is -1 times -1, which is 1. So really what we look for is how many powers, how many fourth powers go into this, and whatever left over is what we really have to look at. So I to the 24th is going to be I to the fourth 6 times, which is just 1 6 times, which is going to be 1. So it really breaks down I to the third, which is going to be here with our negative I. So that's what we're looking at. That's 1, and we get negative I as our piece. Now if we put that into like a graph, we can plot these imaginary numbers, complex numbers. We have a real axis, an imaginary axis. So this value 4 plus 3i is over 4 in the real direction and up 3i on the imaginary axis. And we can start to talk about how we would do this in terms of our polar form. So we have, again, same principle. We rotate an angle and we go out a distance r, and we call this value r the modulus, and theta is the argument. And usually we designate a complex number in polar form as z. And so we have the same principle where the magnitude of z is just from the Pythagorean theorem, the square root of a squared plus b squared. And we have, really just looking at this in terms of right triangle trig, z is this component here, which is r cosine theta, and then it's this component here, which is r sine theta, and we add those two together and we get this value here for z. And we have this so often, cosine I sine of theta, that we have this shorthand notation called cis. So r cis theta stands for r cosine theta plus I sine theta. But keep in mind it's just notation, and we shouldn't worry about it. We can always break it down into, we can always expand it if that's easier for us. And so we can look at how these work. When we are multiplying complex numbers, we multiply the r values and we add the theta values. And so those are our r values. We multiply those two. 2 times negative times 3 is 6. And then we add those values together and we get our final answer for multiplying those. For taking the reciprocal, it's 1 over r and then negative theta, the opposite of it, and we'll look at why this works in terms of division in a moment. But what we do is it's 1/2, and then we take cis of negative 154, where that's going to be cosine negative 154 plus I sine of negative 154. We try to work it all the way out. For division, we divide the modulus, so we divide r, that, and then we subtract our values for theta, and we get negative 77. And so we can use this often to find roots. So we have, if just repeated multiplication, we could expand this. That's what our power is. So if I was to square it, that would be those two values squared to the third would be the third, and then I multiply by n theta to make this work. And so if I'm looking for roots, what that means is if that's my value, I want the third root, that's z to the 1/3 power, and so what I do is I'll have 8 to the 1/3 cis 1/3 of 120 plus 360k, where k is some integer, because these are all coterminal. I could take some angle at 120, which would be over here, and then add 360 to it, and I get in the same spot. So these are all the angles coterminal with it. And so we just now at this point plug through it, and if I actually wanted the values, then I would plug in values for k. So I could plug in 0, I could plug in 1, I can plug in 2, and that's going to give me my actual roots for this complex number.